quarantine. My apologies for the noise. That's the 3D printer working. We're expecting a new batch for tomorrow morning, so it's going to be working out overnight, and it's just going to be printing this entire time through the whole video. So my apologies for that. For everybody who doesn't know me already, my name is Emanuel Wazar. I'm the co-founder and executive creative director for Reality Synthesis Technologies. We're a virtual reality film studio, and we were working the last few months on our own virtual reality project, a very big project, very proud of it. And then, news of COVID in China started emerging, and since then it's become a pandemic, and it's now in the United States of America, and the numbers are increasing every single day. They are drastically increasing day on day, and unfortunately here in the United States of America, we're facing a very serious challenge in our public health response to the coronavirus. To provide background, basically what's going on is anything that has to do with health products, face masks, face shields, respirators, ventilators, valves, medical devices, medical components, across an entire range of need. Basically, there are massive nationwide shortages of these very, very critical products and devices. This is very alarming. More so because the population most affected by these shortages are exactly the most critical populations. They're vulnerable populations like the elderly, minorities, those with poor access to healthcare. And of course, healthcare workers, nurses, doctors, first responders, medical professionals of all kinds are having very serious shortages of all of these products. This is very critical. These are life-saving devices. These are things that both prevent the transmission of coronavirus, both transmitting it to somebody else or being infected by it. In addition, some of these devices are life-sustaining. They actually keep people alive and prevent death. Just in general, any kind of shortage is going to impact heavily the quality of care. It's going to affect the outcomes, the medical outcomes of those who are suffering from infections of coronavirus. So the seriousness of this challenge is very sobering. And we needed to be able to confront this and do something about this. Fortunately, the open source community out there in the world globally is absolutely committed to this. There are people out there really toiling and trying to do their best. In addition to the technology of 3D printing, we live in an age where we actually have the capacity to respond to this challenge, and where manufacturing in the US is kind of deprecated. 3D printing by individuals, by companies, is really able to fill in that gap and provide the necessary manufacturing power to be able to face this challenge that we're facing. So that's where I found myself. I felt that I could best focus and direct the efforts of Reality Synthesis to confront and do the best we can to provide for these supplies, and using our expertise and technical know-how and background to really be able to confront this grave danger. So basically, what I wanted to share with everybody in the community tonight is kind of like, a big picture of what it looks like in 3D printing space in terms of response to COVID-19, to provide a little bit of orientation and guidance in being able, if you want to do your own kind of effort, to kind of get up to speed and start with like the best stuff out there. So, there's thousands, tens of thousands of people all over the world designing, iterating, and working on different devices and products, and building them in 3D printers. There's actually hundreds upon hundreds of 3D models that you could find and search online from different organizations, which is really great, but then it also poses the challenge of really picking what is actually effective and in the field, what actually produces results that are medically sound and medically approved, and ideally medically certified. I live here. This is in Washington D.C. And I'm not that far off from NIH, which is really great. I'm very familiar with them. Some of the best people in the world in terms of health. And NIH right now has a really great program for 3D printing. They've dedicated an entire website for Covid-19 3D printing response. And basically, I've been using their kind of approved devices list, which they have taken out to medical professionals. They have consulted with experts. They've actually taken it out into fields, into local hospitals around here in DC, and gotten feedback from everybody about what works, what doesn't work, what needs to be improved, and kind of iterating on the design of all these apparatus, and making the best designs that we possibly can. Just to walk you through some of the designs and how we've evolved from where we were in the beginning to where we are now. I'll just walk you through some of these. Initially, there was a lot of printing for these. So this is kind of like a face mask. And basically what you're supposed to do with these is that they're thermally adaptive. What you do is use heat to adapt them to your face. And this is what I've done with this one. And basically their filtration system works here. You open this up, it has a filter inside of here. It's got a filter in there. And these basically provide protection, in theory, from COVID-19, from coronavirus. But we found that, these aren't the most effective. It's very hard to get a very good seal on them very well. And the process of thermally forming them is not very accurate. It's kind of finicky, and there's very often you break these. So not the best device. Kind of turned away from these, kind of the general consensus. The next kind of step up was here with a more like rigid face mask, respirator. And the way I got these is so that these are actually linked. You could pre-tighten and basically just take it up here, tighten here, tighten here. And this is very tight. And this is on really, really good. So basically, inside of the internal structure of this, there's a space where you insert this brace, and then in front of it you put a filter, and that's what's right behind this grill. And that's what provides the protection in terms of filtering out viruses from being able to get in. The great thing about this is, since it's tight and solid and hard, it's really not allowing any space for any kind of gaps to come in for air. All the respiration comes directly from here, which is the problem with these is they weren't really working in terms of like filtering out. The breath really wasn't going in the direction of the respiratory hole. So this is really good. One of the main issues I have with this is the braces, the latches for where the braces aren't really the best. They're a bit too small, hard to adapt and hard to use. And also, because this is very thick, it's very hard to talk. So I probably sound very muffled right now. This is a really big concern because you need to communicate effectively. This is not exactly satisfying that. So from this model, kind of researching, we moved on now to Montana mask. This is what it's called. Basically, it's a lot thinner. You can tell from the walls, it's a lot thinner. And also the latches are a lot more open, a lot more easy to lash things through. They operate very similar. They have a screwed-on respiratory cap, and you put a filter in here. You attach this thing here, and then you use a similar elastic harness to attach them to your face. These cover a lot more surface area, and probably if you're listening, you can hear me a lot better, which is kind of a very critical detail. So this is actually a much better mask in my opinion. And that's kind of the model that I've settled on in terms of like mass production. As of right now, that's the one I'm going to be using to provide for everybody. In addition to face masks, the other main concern in terms of transmission are the eyes. the eyes are, susceptible to viral infection. And so it's one of the ways that, coronavirus is infected. So to kind of address that, uh, they've been developing all kinds of these very similar face shields where you put a protective layer in front of you. And they generally kind of come in this shape, like here originally. But once these started being tested in the field and getting feedback from kind of nurses and other healthcare professionals, there were some problems with that. And from the NIH, this is like their latest model. One of the main concerns that they had here is like these guard plates here. A lot of the medical professionals are actually at an angle when they're working with the patients. So there's concerns about aerosolized particles or splatter or spray that's in the air or lands on the head or hair. And this kind of guard protects from that, which is very critical. Also, having a 3-hole punch where it's easy to just create 3-hole punch. You get something like this. Of course, this is with my very limited supplies. I need transparency paper. I need real elastic bands, not rubber bands, and some better foam padding. But I've kind of developed this kind of an implementation, and the idea with this is that you basically put it over your face like this. Now this completely protects your eyes, protects the side of your face as well. It allows a range of mobility. It's comfortable with the foam padding, and with adjustable elastic bands, it's a little bit more comfortable in the back. And so the idea with this is basically that you would have this and the mask on at the same time, and this would be washed with different elastics. And I mean, this is you're not transmitting or getting any kind of coronavirus from that. So this is kind of where we're at in terms of my two main products that I'm developing and printing in mass. A question that often comes up is in terms of sterilization concerns. I mean, how to get these where they're safe to be able to distribute and use on a frequent basis. So kind of consulting with medical experts and even from the NIH, these kind of products really aren't compatible with heat. They'll actually melt. So you can't use like heat sterilization, which would often be used in for medicine or medical equipment. But you can use chemical sterilization processes, chlorine, bleach, very effective at just cycling through these and cleaning them and making sure that they're not contaminated and they're safe to use. The one limitation in terms of chemical is with acetate. These will actually melt with acetate, so you don't want to use that. But chlorine and bleach, very, very effective, and basically, just like every time you'd wash your hands, every time you're using these or you get back home, immediately go and you clean it up. You let it sit for a good while in these substances, and you let it dry out, and it's good to go and used again. Wash it down. So that's the approach with that. And this, I'm reaching out to the public. If you could help me out getting those supplies, that would be really great. It's kind of one of the areas that I'm in need. The more the merrier. If you have resources or contacts that are able to provide this, please let me know. So yeah, this is kind of where I'm at now. This is where I've just been designing things here in my house. And I'd like to give you just a really quick rundown of the actual 3D printer, so you have an idea of how the 3D printing process kind of works, and you're going to have some familiarity with that, okay?